All right, now what we want to talk about is insulation resistance. And so the first thing I'm going to talk about is that we perform insulation resistance as a DC test. The main reason behind that, some people want to know, why don't we use AC for insulation resistance? Well, one, you don't have to worry about a sloppy waveform. If you have any DC test that says 500 volts, it's 500 volts coming out of there. It's constant 500, it's not changing. It's not ugly, it's not stepper waves, it's not anything crazy, it's just flat DC. That's one reason. The next reason is because it's a very small test set. It just has to get up to charge, and then, I mean, these are battery-powered insulation resistance test sets. Very, they don't have to plug into a wall. If you did AC, it would have to plug into a wall just to get the same amount of power out of it, okay? The last reason is because you can start to do other things with the DC, such as polarization, and you can start checking the quality of your insulation based off of polarization indexes and DARs as well. Okay, so that's why we use DC. So now let's talk about how do we do it, okay? So insulation resistance, when you measure insulation resistance, I've got this meter right here. I've got several flukes here, and I have other meters other than flukes, but I'm using the flukes because everyone trusts a fluke, right? So I don't wanna stray away from something that most people completely agree with. So if you do insulation resistance, we're just going to test normal resistance. We're going to go from here to here. What do we expect that to be? 0 practically, right? We're testing the same conductor. Now, if I go from here to here, I expect that to be the insulation of this equipment. And so I actually installed two 500 mega ohm resistors over here. And so it's 500 mega ohms or less, but it's much higher than that meter can read. And then here's the same one as well, and here's the same one else. So I can't use this meter to measure anything anywhere near 500 ohms, okay, or mega ohms, all right? But it can meter, 1.7. If I take these two and I put them in parallel, now I know that two 500 mega ohms resistors are in parallel, should be 250 mega ohms. And so if I measure it right here, I still don't get it. So it can't measure 250 mega ohms. Okay, so that's why we can't use this meter. This one is going to do the exact same thing. I just want to show you that there's nothing crazy going on here. It's practically the same. It gives us a better reading for sure on just the same bar. So that's definitely a good plus for this meter. But still, it won't get anywhere near our 500 mega ohms. So now let's go over to our other meters that we have over here. Now these ones are actually mega ohm meters. Okay, these are designed to perform this test. Now I have done another video proving that this will run up to 5 kV and give you some substantial readings. So I know that we can run this at 5 kV, but we're going to start out low. Okay, this test set right here puts out about 8 volts at the most, and it tries to measure the current. That's how we measure resistance. We can't actually measure resistance, we only calculate it, okay? So in order to calculate it, we have to apply a voltage and then measure a current. But if we turn on this little meter right here, and we're just gonna measure this at 250 volts, all right? I'm gonna clip it on here. I'm going to slide it back this other way. Remember, we still have these two 500 mega ohm resistors down here in parallel, so they act like 250 mega ohms. So I'm going to slide it this way so now you can see my leads are on there, right? So now that we're all set up, I'm going to press test. We're going to see what it meters. Oh, I have to hold the button. There we go. 250 mega ohms, right? You won't turn the light on while it's running. Turn the light on, there you go. 250 mega ohms, right? These won't read that. But how about this? Let's do one more step and let's check. Is this meter actually putting out 267 volts? Well, that means that there should be 267 volts across these phases, right? And my red one is on the red and my black one on the black, so I should have 267 volts. Pretty much spot on the dot, but if you look, my meter just changed to 10 mega ohms, okay? So what is that telling me? I'm gonna take the voltage off for a second, right? You saw it went away over here too, so that's a good function check. Take these resistors off, and now I'm gonna do it one more time. And what is this telling me? This is telling me that the input resistance of this multimeter right here is about 10 mega ohms, okay? And it's roughly about the same for this other one over here. I'm gonna turn every light on if I can. You go over here, this one still says 265 volts DC, and this one says 9.5 mega ohms. That's the input resistance of these meters is about 10 mega ohms. Okay, and that's why they can't read. But these megas over here, they sure do. And I'm going to turn on this other one. We'll go up to 2500 volts, and we'll just test this bus and see what it says. And it says that with no resistors hooked up, we've got about 9.5 giga ohms and climbing, right? So we've got a polarization that's building. Okay, so that's why we need these meters, and that these ones won't do the job for insulation resistance, okay? It's just, it can't measure values that are that high, and I'll talk about why in the next video.